Building science is a really interesting topic where you look at the internal and the external conditions that affect a building system, and you can calculate the energy balance, the heating losses and the cooling losses, and you make decisions, mathematical decisions that will balance occupant comfort inside. So not just the health and wellness of the occupants, but also the proper functioning of equipment. And when we're talking about building science in terms of the conditions that affect a building system, and when we're talking about building science in terms of conservation and in terms of moving to a lower carbon way of building, constructing, and renovating, then we should always remember that in our efforts to make energy conservation, we should not be cutting back on comfort. So we have to always keep comfort in mind and find ways of our technology to be used to maintain that comfort, to maintain those comfort conditions at lower energy consumption. We should be using less energy in order to do what we want the building to do. So when we're talking about building systems and HVAC systems and designing a proper building envelope and use, we have to remember that we need to control the atmospheric conditions and control the thermal conditions for a few reasons. First of all, what we call comfort conditions. Comfort conditioning means we will have occupants in the building, and we have to think about the health and the wellness of those occupants. And also we control the conditions of our buildings also for proper functioning of the equipment in those buildings. And this is called process air conditioning. So the organization that we follow in terms of the conditions that affect a building system is called ASHRAE. It's the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This is a professional organization that you're going to hear about over and over the more you get into building science. So ASHRAE supports and conducts the research of heating, refrigeration, and air conditioning, or HVAC systems and beyond. They make standards and they publish standards that are accepted throughout the entire industry. And those are the basis of all of the building codes. So ASHRAE says it calculates what the standards ought to be, and building codes need to make practical recommendations that will ensure that the buildings meet the ASHRAE standards. In Canada, there's another institute that you're going to come across, and that's HRAI, the Heating, Refrigeration, Air Conditioning Institute of Canada. And that's also a good reference for you more on the skilled trade side. So here in Canada, approximately 20% of the total energy consumption is just directed towards comfort cooling and comfort conditioning. And that's quite an opportunity to be able to conserve energy. We're going to look at some specific comfort conditions. So we're going to look at the temperature of the surrounding air inside a building, and that's called the ambient temperature. That ambient temperature is important for proper functioning of equipment and your comfort, the occupant comfort. It's important to know the radiant temperature of surrounding surfaces as well. That's called mean radiant temperature, MRT. The humidity has a major effect on building occupants' comfort and the durability of the building and proper functioning of equipment. Air motion is something that you might not have thought about before, but you will find that once you learn about the impact of air motion and how you can best control the motion of the air, that it plays a major factor in the comfort of an occupant. So as we're thinking about all of these comfort conditions, we have to keep one thing in mind, that if you are in a building, and think about the building you're in right now, if you are in a building, are you aware of the temperature? Are you aware of how cold it is or how hot it is? Are you aware of some air motion that is perceivable to you or that distracts you? Are there any noises that are that are sharing your train of thought? So in a properly conditioned space, we want to make our buildings such that your body, the occupant's body, can reach equilibrium. So when your body is sitting in equilibrium, it's not trying to get colder. It's not trying to get hotter. It's not thinking about that noise it can feel. And it's not distracted by the motions of the air circulating around you. If you are in equilibrium, you are not thinking about your space. You're not thinking about any atmospheric conditions, and your body is not using any of its energy to get to a different atmospheric condition. And that is what ASHRAE seeks to define as a properly executed comfort condition.